So today we're going to be talking about quadrilaterals and the vocab that goes along with the quadrilateral property. So the first vocab word we're going to talk about is perpendicular. And perpendicular means to intersect at a 90-degree right angle. So we're writing intersecting or intersects. Oops. At a 90 degrees right angle. So an intersection, just like whenever you're driving down the road and you come to a red light, that's an intersection, is when the two lines are crossing, and when those two lines cross, this in-between part is a 90-degree angle. The next vocab word we're going to talk about is bisector, and bisector is to cut in half at an intersection. So over here we have our bisectors. They're cutting our shape in half, and there's this intersection. So here's a bisector and here's a bisector. And each side of that bisector is congruent. They are the same length. And this isn't always true, but can be true with a lot of shapes. The next word we have is congruent, which we've heard before. It's when two figures are the same shape and same size. We learned about congruent when we learned about similar figures. It just means that they're the same looking shape and they're the same size. So next we have adjacent. And adjacent means next to each other. So this line is adjacent to this line. They are next to each other. Or this line would be adjacent to this line. They're next to each other. This line would be adjacent to this line. They're next to each other. And then we have this word, which is parallel, and you can remember parallel by the two L's. So parallel is when lines that they are lines that will never intersect, so they'll never cross. So lines that will never intersect. So they're never going to cross. Like the L's in parallel will never cross. Parallel lines will never cross. So now we're going to turn the page to the back. We're going to talk more about quadrilaterals. So first we're going to talk about parallelograms. In parallelograms, they have opposite sides and angles congruent. So opposite sides and angles congruent. So what that means is, I'm going to change my color here. This side, its opposite would be this side, and they are congruent. They're the same length. There's also this side of our parallelogram and this side that are also congruent. And I want you to make sure you're drawing these lines. It said opposite sides and angles are congruent. So that also means that the angles that are on opposite sides are congruent. So this angle right here would be congruent to this angle. They're the same size, they're the same degree. Or this angle, and when we draw our second arch, we need to put two arches so we know that we're talking about this angle, that they are congruent. They are the same size. So the opposite side, this purple, is the same length as this side. The green side is the same as this side. This angle is the same as this side, and this angle is the same as that side. A little confusing, a lot of words. Sorry. So then we have opposite sides are parallel. That's why it's called a parallelogram. So that means that this side over here and this side over here will never touch. They're going to go on and on and on forever, and they'll never ever touch over here. You don't have to draw those. Or these sides, both sets of sides are parallel. They'll both go on and on and on and on forever and never touch. And the last blank we have is diagonals bisect. So we're going to follow our little arrow up here. So if we bisect the diagonals, you can use a ruler if you need to. This side of our bisector is going to be congruent to this side. And now you can see that the angles here are a little bit smaller. They're a little closer together. where these angles are further apart. So that means that this bisector and this will be congruent to this side because it's a little bit longer. So each side is congruent, but they are not all four bisectors congruent. So then the next shape we're going to talk about is a trapezoid. And exactly one pair of opposite sides are parallel, the bases. Exactly one pair. And if you look, there's only going to be one side. If these lines right here go on and on and on and on forever, eventually this line's going to cross it. So those set of sides will never be parallel. Where these sides here and here, the bases of the trapezoid, if they went on continuously forever, they would never touch. So now we're going to move further down our page and we're going to talk about rectangles. So rectangles, opposite sides are congruent and parallel. So opposite sides are congruent, so each side of our rectangle, this side would be congruent to its opposite side, which would be the bottom. This side would be congruent to this side. And notice how I'm putting two lines versus the one line because these, all four, are not the same length. So the two lines is showing us that this side is congruent to this side. And then it also says that they are parallel. These sides, this side and this side, will never touch. They go on and forever. This side and the bottom will never touch. Next we have all angles are right angles. So when we have angles, we know they're right angles when they make this little box in the corner. So that's a right angle, that's a right angle, that's a right angle. So all angles are 90 degrees. And the last blank we have is diagonals bisect and are congruent. So when we were talking about parallelograms, not all bisectors were congruent. This time with rectangles, they are. So over here in our little picture, we're going to bisect our rectangle. So this side of our bisector is going to be congruent to this side. This side will be the same length as this side, and they're all going to be the same length. And now we're going to talk about a rhombus. All sides congruent, so all sides of the rhombus are congruent, so they're all going to be the same length. So every side is going to just get one tick mark, because they're all the same length. And opposite angles are congruent. So this angle, let me change my color, this angle is going to be congruent. This angle is going to be congruent to this angle. This angle over here is going to be congruent to its opposite angle, which is over here. They're going to both be the same length. Or not the same length, the same degrees. And then opposite sides are parallel. So if this side and this side go on and on and on forever, they're never going to touch. Same with this side and this side. And our last blank, diagonals are perpendicular bisectors. So when we draw our bisectors in here, draw them in, they're going to be perpendicular, and perpendicular means that they intersect at a 90-degree right angle. So we can put that little square we put in for right angles in that corner. And then this side is congruent with this side, and this longer side is congruent with this side. So not all bisectors are congruent. Okay, now we are going to look at our last shape, which is the square. So for a square, all sides are congruent, so that means all sides are the same length. So this side is just as long as this side is the same as this side. They're all the same length. So all angles are right angles, again, just like rectangles. So this is going to be a right angle, this angle will be a right angle, here will be a right angle, and here will be a right angle. Diagonals are congruent perpendicular bisectors. So if we go over to our rectangle and we bisect this, they are going to be perpendicular, and that perpendicular means that they intersect at a 90-degree angle. That's what that little box shows us. And the bisectors are perpendicular. So that means that this side is as long as this side of our bisector, this side is congruent to this side. And then our last blank, opposite sides are parallel. So this side is parallel with this side, just like our parallel lines, and the top is parallel to the bottom. Okay, so we're going to start, or what I'm going to have you do is fill this page out by yourself. You are able to use your notes that you filled in so far. I want you to fill it out to the best of your ability, and then we're going to go over the answers and talk about them. So go ahead and pause the video. Okay, so opposite sides and angles are congruent. So let's check. So looking back at our notes, we saw that opposite sides are congruent, opposite sides are parallel, and it's talking about all sides are parallel, which normally means it's a parallelogram. Next shape we have, it says opposite angles are congruent. So we have opposite angles congruent. Opposite sides are parallel. Diagonals are perpendicular bisectors. And looking back at our notes, we see that this is a rhombus. Then we have our next one, and I think we all know this one by looking at the picture, but we're going to look through it anyway. It has the properties of a parallelogram. So it has opposite angles are congruent. So opposite angles are congruent. Opposite sides are parallel. Diagonals bisect each other. All angles are right angles, and diagonals are congruent. And this is a rectangle. Then we have this one, and I'm sure we probably all know this one. It has the properties of a rectangle. All sides are congruent, diagonals are congruent, and the diagonals are perpendicular bisectors. It's a square. And then we have this one. We didn't go over this one together, so it's okay if you didn't get it. So adjacent sides are congruent, perpendicular diagonals, one pair of opposite angles are congruent. And this is a kite. And then our last one, exactly one pair of opposite sides are parallel. It is an isosceles trapezoid. In an isosceles trapezoid, the diagonals are congruent, the bases are parallel. And the bases are parallel, and this is a trapezoid. Okay, flipping to the back. So this is called the always, sometimes, never chart. And I want you to study the always, sometimes, never chart for your test.
Please excuse this interruption. Braden Danley, if you're...
So I want you to study the always, sometimes, never chart. And the way it works is, if you memorize this chart, you will know a lot about shapes, even if you don't know everything. So they're very helpful. So when you go up on the chart, it's always. So if we were looking at square, a square will always be a rhombus, it'll always be a rectangle, it'll always be a parallelogram, and it'll always be a quadrilateral. So like a kite, if we're going up, will always be a quadrilateral, or a trapezoid will always be a quadrilateral. Sometimes, so that means that it can sometimes be that thing. So like a quadrilateral can sometimes be a parallelogram, a rectangle, a square, a rhombus. It can sometimes be a kite, it can sometimes be a trapezoid, but not all the time. Or, for example, if we look at rectangle, a rectangle can only sometimes be a square. Or a parallelogram can only sometimes be a rhombus or a rectangle or a square. Then we also have the never. The never means this way. If we ever go this way on the always, sometimes, never chart, it won't ever work. So a rectangle can never be a rhombus. A kite can never be a parallelogram. A kite can never be a trapezoid, just like a square can never be a trapezoid. It can never be those things when you go this way. So we're going to do the first couple together. So is a rhombus a square? So here's rhombus. And the directions tell us answer the following with always, sometimes, or never. So can a rhombus be a square? We're on rhombus and we're going down. That means sometimes. So a rhombus can sometimes be a square. Okay, our next one for number 2. Is a square a parallelogram? Well, we're looking at square. And we're going up to parallelogram, which means an up arrow. So that means always. Our square is always a parallelogram. It'll always have the properties of a parallelogram. Is a rectangle a square? A rectangle, and we're going down, and down means sometimes, so sometimes a rectangle can be a square. Is a parallelogram a trapezoid? Well, parallelogram's here and trapezoid's over here, which means we're going side to side, and side to side means never. So a parallelogram will never be a trapezoid. Then we have a rhombus. Is a rhombus a rectangle? Well, rhombus is here and rectangle is here, and that means we're going side to side. So if we're going side to side, that means never. So is a rhombus a rectangle? No, it'll never be a rectangle. So what I want you to do is work on 6, 7, 8, 9, and 10, and 11 by yourself. Once you have those answered, you can go ahead and hit play. So go ahead and pause the video. So let's go through and check your work. Is a square a rhombus? We have square here. We're going up. So a square is always a rhombus. Is a kite a trapezoid? Well, kite's here, trapezoid's here. We're going across. So that means never. Kite will never be a trapezoid. Is a parallelogram a rectangle? Well, here's parallelogram and here's rectangle. We're going down, so sometimes a parallelogram can be a rectangle. Is a square a rectangle? Well, square's here, and we're going up to rectangle, and up means always, so a square will always be a rectangle. Is a quadrilateral a trapezoid? So we're on quadrilateral, and we're going down to trapezoid, and when we go down, it means sometimes. So a quadrilateral will sometimes be a trapezoid, but not all the time. Is a kite a quadrilateral? Well, kite's here. We go up to quadrilateral, and that means always. So a kite will always be a quadrilateral. And that's how you use the always, sometimes, never chart. I want you to make sure that you study this chart because there's going to be questions on your test where you have to do answer questions just like this. And this chart is amazing at helping you. So today we learned about quadrilaterals and their properties. Make sure you are studying at home and remembering the always, sometimes, never chart.